welcome back to another science experiment video. I've decided to name this segment All Things Science with Miss Muhammad. So thank you everyone who has watched and subscribed, especially those of you who are not particularly my students. I am so grateful that you all enjoyed my first video, and I hope that you guys will continue to enjoy the content that I put out. So today we will be making elephant toothpaste, and it's pretty much exactly what it sounds like. So we know toothpaste is foamy and thick, and our experiment today is going to look exactly like toothpaste, but it's going to be the size or big enough for an elephant to use. Alright, so let's get into our materials because we have to do a little bit of prep work. Alright, so for our materials, you are going to need a water bottle, and I just have a makeshift funnel taped on top. You're going to need some active yeast, some dish detergent, hydrogen peroxide, and I have 3% hydrogen peroxide. The higher the percentage, the bigger your reaction would be. So if you can find stronger peroxide, then I would suggest it. You're going to need a measuring cup, a spoon, a large bin, and I will also suggest doing this in a space that you don't mind getting messy or outside because the foam can get everywhere. And then a little container for your yeast. And before I explain the experiment, I am just going to start by activating my yeast because this is going to take a couple minutes. All right, so I'm activating my yeast. So I have 4 ounces of warm water, and it's really important that it's warm. And then I have my yeast. I'm going to sprinkle it on top, like so. And then I am going to just stir it up. Okay, so as our yeast activates, I'm going to get the rest of our materials together, and I'm also just going to explain what is going to happen for each thing. Alright, so I'm going to start by putting my bottle inside of my container, and then I'm going to get half of a cup of hydrogen peroxide. And pour it. Alright, so I have my peroxide in. And for this experiment, the hydrogen peroxide is going to be decomposing. So this is actually a decomposition reaction. So in math, if you were in my math class, we know all about decompositions. And decompositions, or when we decompose numbers, we're breaking a big number down into 2 smaller numbers. Well, for our hydrogen peroxide, we are going to be breaking it down into 2 molecules. And so hydrogen peroxide is made up of hydrogen and oxygen, and these are both gases, but when they form, they can create a liquid. Now, when we decompose our hydrogen peroxide, it is going to break down into water, H2O, and it is going to break it down into oxygen gas. And the oxygen gas isn't something that we can see. It's just kind of like, it just goes into the air. Alright, so we are decomposing our hydrogen peroxide. We are breaking it down. Alright, so our next ingredient that we need is some dish soap. And you're going to need 1/4 cup of dish soap. Alright, and I'm going to just give that a whirl to make sure that they are mixed up very well. So you might be wondering, what do we need dish soap for? Well, remember, we're making elephant toothpaste, and the best thing about toothpaste is how foamy it gets. Well, what does this dish detergent do? It makes bubbles, and it can get really sudsy. Now, what's going to happen is when we are decomposing our hydrogen peroxide, when it's breaking down, those oxygen molecules and oxygen gas that is being released, generally, it would just want to fly up in the air. But what's going to happen is the oxygen is going to get trapped inside of the dish soap, and then that's what's going to make this big foaming reaction. I'm so excited for you guys to see. Alright, so moving forward, so this next step is optional. You do not have to do this. Alright, but I'm going to add in some food coloring. Alright, so the last thing that we have to add is our yeast, and the yeast is still foaming or activating, so I'm just going to leave it alone for a little bit longer. But while we're waiting for our yeast to activate, I'm going to explain the purpose of the yeast. So yeast is something that we usually use to cook with, to make bread, pizza dough. It makes things nice and fluffy. Now in this reaction, our yeast is actually going to be a catalyst, and a catalyst is something that speeds up a reaction and makes it go really fast. Alright, and this is going to be super important for our experiment to work. So, so our yeast is going to be our catalyst. Now, there's also something really special about this reaction. This reaction is an exothermic reaction. And if you know anything about thermometers, you know that they take our heat. Well, or our temperature. Well, when we do this reaction, it is exothermic, which means that it's going to produce heat. It is going to get warm, and it's really important that we're wearing our protective gear to make sure that we're being safe. So, and that we don't touch it. You really don't want to touch it because it could burn your skin. Now, this is a safe for home experiment, so it should just get warm. It shouldn't get too hot. But if you're using stronger peroxide than me, or if you tried the similar experiment but with different chemicals, it's really important that you don't touch it because you can really hurt yourself. So especially like scientists, when they do this experiment in a lab, they don't use yeast or even the dish soap. They use some other chemicals with the really strong hydrogen peroxide, and you can just see the steam and the smoke coming off of them. So I would really suggest you also go watch elephant toothpaste in a scientific lab and see how it looks and how it's different from my version. Alright, so I am back and our yeast is pretty activated. I think it is ready. But let's just get into it. Alright, so as soon as I pour my yeast in, I'm going to remove my funnel so that the experiment can go. And alright, here we go. 3, 2, 1. Oh yeah, okay, so I can see things foaming. It still isn't giving as quick as a reaction as I expected, but I think a lot of that does have to do with the fact that the hydrogen peroxide isn't as strong. Alright, here it goes. We're so close, a couple seconds. And I'm being sure not to touch it because this is an exothermic reaction. It's producing some heat. Wow. So it's foaming out and it definitely looks like some toothpaste. Alright, so while this is still going on, let's recap some of the things that we learned about in this experiment. There were 3 main terms that we learned. So the first one was that this experiment is a decomposition reaction. Remember, we connected decomposing back to math class. And a decomposition is when we're breaking something down. So for today, we decomposed or broke down our hydrogen peroxide into water and oxygen gas. So once this reaction is completely done, any of the liquid that will be left in should just be water. It won't be safe to drink though, and it will be mixed with food coloring. And then all of the oxygen has been trapped and mixed inside of the dish detergent, and it is making this nice foamy mixture. Alright, so our first term was a decomposition reaction. The second term that we learned today was a catalyst, and the yeast in our experiment was the catalyst. A catalyst in an experiment is something that speeds things up. It makes it go really fast. The third term that we learned today was exothermic reaction. So an exothermic reaction is one that produces heat. So when our hydrogen peroxide and yeast and dish detergent react with one another, they produce heat. So if I touched it, it would be very warm, but I'm not going to because I want to make sure that I'm safe. But if you do have to touch it to clean up and things, that is why gloves are so important. Or just give it time for it to, cool down. Alright, so I really hope that you guys really enjoyed this experiment. Thank you again so much for tuning in. I'm going to keep this going for as long as it will, and I'll just speed it up and add in a time lapse. And then also at the end, I'll have some other bloopers so you can see all of my trials that I've done of this experiment that I recorded. So thanks again for tuning in, and I will see you again next time. Bye!